Welcome to the debate. Imagine taking a Formula One engine. I mean, a machine capable of just mind-bending speeds, engineered for absolute precision. And then you fuel it with cheap lawnmower gas and drop it right onto a bumpy dirt track.
Yeah, it's going to stall out almost immediately.
Exactly. But when that engine inevitably stalls, do you blame the engine or do you blame the track?
Well, society usually blames the engine, right?
Right. And today we are looking at highly complex specialized systems. Now, whether that system is a multi-billion parameter artificial neural network or, a profoundly gifted, twice exceptional human mind, we tend to force them onto the exact same dirt track.
Yeah, we place them in these flat, standardized baseline environments. We assume their underlying brilliance will just, naturally shine through.
We assume the baseline is just a neutral testing ground, like it's simply an empty room where the system can operate without interference. But then you look at the actual data of what happens when these spiky, specialized systems are forced to interact with those standardized baselines.
And it's not pretty.
No, it's not just a minor dip in performance. It is catastrophic data loss. It is systemic failure. And that brings us to the central question we are exploring today. How do we solve this profound incompatibility?
Right, because there's a huge divide on this.
Exactly. Is the answer found in precise, multi-dimensional measurement and algorithmic transparency? Or does it require a fundamental architectural overhaul of the interaction itself?
Now, I approach this issue squarely through the lens of algorithmic evaluation.
And I approach it from a socioeconomic and, a bioenergetic perspective. Right. So my argument is that this systemic failure is fundamentally a sampling and measurement error. Standardized baselines fail because they rely on uniform random sampling that hides massive blind spots. The solution is what the literature calls benchmark transparency. We explicitly map the data to predict and account for performance drops. We don't need to completely rebuild the track, we just need to measure it correctly.
Yeah, and I argue that measurement is entirely passive, and frankly, it's insufficient. Flat baselines are not neutral. They are aggressively optimized for low complexity, and they actively devalue complex assets.
Which is a bold claim.
But it's true. When a specialized, twice exceptional human mind, often referred to as 2E, interacts with a standardized environment, it's not just a measurement error. It is an active bioenergetic incompatibility that triggers a systemic biological shutdown. Yes, to solve this, passive observation won't work. We require structural interventions, specifically what the research calls peer-to-peer joint investments and strict gating protocols to prevent the system from going offline entirely.
Okay, so while I'm looking at this through the lens of artificial neural networks, you're looking at human neural networks, specifically neurodivergent minds, and seeing the exact same failure mechanism.
Exactly the same.
Let's lay out our positions a bit more clearly, starting with the evaluation framework. The core of my argument rests on a comprehensive natural language processing study examining 135 different models.
Which is a massive sample size for this kind of thing.
It is. Now, 125 of them were tested on the SQUAD dataset. That essentially tests a model's ability to read a passage and extract the right answer. The other 10 were tested on the multi-NLI dataset, which tests logic, like whether one sentence logically follows another.
Right.
What this research demonstrates is that a model's performance fluctuates massively based on unseen data dimensions. We are talking about a variance of 6 to 12 points in their F1 score.
That's a huge margin.
Right. For those listening, the F1 score isn't just about raw accuracy. It's a balance of precision and recall. It measures whether the system is getting the right answers without missing the subtle ones. A 12-point swing is a massive drop in reliability.
It really is. It renders the test almost useless.
And the standard baseline fails because it relies on uniform random sampling. It makes this flawed assumption that all the test data is equally representative of the real world. But the researchers quantified the data across 6 specific orthogonal dimensions: ambiguity, difficulty, discriminability, length, noise, and perplexity.
So they basically mapped out all the hidden variables.
Exactly. By doing that, they could explicitly calculate a dataset similarity vector. In plain English, if we measure the specific quirks of the data environment, we can predict exactly how a model will perform when it encounters weird, out-of-distribution information.
Okay.
So the solution to baseline failure isn't overhauling the architecture of the system. It is total transparency and rigorous measurement of the interaction environment.
Look, I understand the appeal of a clean, predictive metric. I really do. But the failure of flat baselines goes far beyond predictive modeling. It is a biological and socioeconomic reality that actively destroys value.
Destroys value how?
Well, if you are listening to this and you've ever felt like you have to, dumb down your thoughts just to be understood at work or in a social setting, this is exactly the bioenergetic drain we're talking about.
Ah, okay.
If we look at the socioeconomic payoff matrix, we see that standard public-facing metrics are structurally, intentionally dumbed down. They operate as a 1% lossy channel.
Meaning they strip away 99% of the nuance?
Exactly. Now, imagine a spiky, elite, twice-exceptional transmitter. When this transmitter tries to force uninsulated, highly complex emotional or intellectual content through that tiny 1% standard channel, the data doesn't just drop.
It creates friction.
Worse than friction, it triggers an involuntary bioenergetic shutdown in the receiver's prefrontal cortex. Specifically, it triggers the KATP channels to close. The result is 100% data loss. The receiver completely freezes.
Oh, wow.
Yeah. And the transmitter is left draining their astrocytic energy trying to force a connection. Passive measurement, no matter how transparent, will not stop an astrocytic ATP drain that approaches negative infinity. Avoiding this requires active architectural protocols to secure mutual bioenergetic homeostasis.
Okay, hold on. Before we move into the actual interventions, we really need to dive into the nature of this systemic data loss. Because you just mentioned an astrocytic ATP drain that approaches negative infinity.
I did.
And for those of us who aren't neurobiologists, what exactly is happening to the brain here? Are you saying these individuals are literally burning biological calories just trying to translate their thoughts?
Yes, literally burning calories. In biological systems, and even in socioeconomic systems, this data loss is not an evaluation illusion. It is a localized, systemic crash. Astrocytes are cells in the brain that help regulate energy, specifically ATP, which is the biological currency of energy.
Right, the fuel.
Exactly. So look at what the matrix calls Action I, Standard Safety Conversations. This is the default mode of public interaction. We talk sequentially, we use uninsulated verbal language, we keep it light. This channel requires you to subtract specialized data to fit the pipe.
You have to compress yourself.
Right. And when the 2E individual attempts to use this channel, the extreme friction creates a localized working memory overload in the receiver. They are chronically exposed to uncompressed, dense data, which triggers that prefrontal overload and the involuntary KATP freeze state just to save energy.
So the receiver's brain essentially trips the circuit breaker.
Exactly. Meanwhile, the transmitter is caught in an open-loop data trap. They are running their astrocytic engine in reverse, spending massive amounts of metabolic energy trying to heat a disconnected room. They get a payoff of negative infinity? It's complete topological isolation. You can't just measure that away.
Okay, I hear what you're saying about the biological shutdown. I see why you think that, but let me give you a different perspective.
All right, go ahead.
Isn't the bioenergetic shutdown you described simply the biological equivalent of an out-of-distribution, or OOD, failure?
How do you mean?
Well, think about it mechanically. In machine learning, an OOD failure happens when you train a model on, say, photos of cats and dogs, and then you ask it to identify a picture of a toaster.
Right. It doesn't know what to do.
Exactly. It hasn't been parameterized for that. It crashes, just as an NLP model drops in accuracy or F1 score when it is fed highly anomalous data. The human system crashes when fed data outside its standard distribution.
But it's more than just.
Let me just finish this thought. The root problem isn't the communication channel itself, but our failure to properly sample, quantify, and prepare for the input. Consider that NLP study again. When they mapped those 6 data dimensions, they found that difficulty impacts F1 scores with 92 to 95% statistical significance.
Okay, but
Furthermore, 4 out of the 6 tested data features alter the evaluation outcomes more than simply changing the evaluation metric itself. The system isn't breaking. Our measurement tool is just failing to capture the complexity of the task it's been handed.
I disagree.
But if we knew the exact standardized mean difference of the incoming data, we could condition the interaction appropriately. We are describing the exact same mechanism of failure, but you are attributing it to the channel's architecture rather than the lack of data transparency.
It is not just an OD failure because the baseline actively resists the complex data. It's not just surprised by the data like an AI looking at a toaster. It is metabolically incapable of processing it without scaffolding.
Incapable?
Yes! The standard baseline caters to flat metrics. When you have a mismatch, say a payoff, where the transmitter is at -5, due to high translation friction and emotional vulnerability, and the receiver is at +2 because they prefer peer-to-peer alignment but lack structured visual schemas, the system doesn't just produce a lower score.
It completely stalls out.
It stalls. The biological hardware actively protects itself by closing those KATP channels, halting cognitive processing to save energy.
Which brings us to the intervention. How do we actually solve this? It really comes down to this philosophical divide. Do we build better thermometers to realize how cold the room is? Or do we start building insulated jackets?
I think you know my answer to that.
I do, but I maintain that predictive vectors, the thermometers, are the most scalable, robust solution. By calculating the standardized mean difference across our 6 dimensions, ambiguity, difficulty, discriminability, length, noise, and perplexity, we can generate a precise dataset similarity vector.
Okay.
In the NLP research, they took this vector, trained a simple linear regression model on it, and were able to accurately predict out-of-distribution performance. They achieved huge improvements in mean absolute distance. Think of it like evaluating a submarine by testing it in a swimming pool.
The standard baseline being the pool.
Exactly. The standard baseline assumes uniform random sampling. It's calm, it's flat, but by measuring the noise and difficulty of the actual ocean, we generate a mathematical vector to predict the hull's integrity out there in the deep water. And we do this without needing to structurally alter the submarine itself.
I'm sorry, but I just don't buy that. Let me tell you why.
By all means.
Predicting the crash doesn't prevent the crash. Going back to your analogy, I say they are freezing to death while we read the temperature. Knowing the hull of your submarine is going to crush at a certain depth doesn't help the sailors inside when you send them to that depth.
Well, to bypass the KATP bioenergetic break, you have to structurally alter the interaction. The matrix outlines 3 absolute architectural protocols required for this. Protocol I is closing the open loop port. This is a zero-trust, self-securing firewall.
What does that actually look like in practice?
The specialized transmitter must refuse to let vital astrocytic bioenergetics leak into unreciprocated dark channels. They have to establish independent projects so their survival doesn't depend on a single uninsulated edge. They have to stop trying to force their data through the 1% lossy channel. But a zero-trust firewall essentially means completely withdrawing from the standard baseline if it doesn't meet exact specifications. That seems highly restrictive. You're just walling the system off.
It's necessary for survival, but it's only the first step. Protocol 2 is where the actual translation happens, which is standardizing the prep scaffolding.
Prep scaffolding.
Yes, to ensure what the text calls emotional photons survive transmission without scattering, you must package complex information into linear, easily digestible packets. PREP stands for point, reason, and example. Point.
Okay, and how exactly does an acronym bypass a biological free state?
By drastically reducing the cognitive load. Think of it this way. By putting the point first, you give the receiver's brain a filing cabinet. Then the reason and example act as the files going seamlessly inside. Finally, you restate the point to close the drawer.
I see.
Without that specific sequence, the receiver's brain is just juggling loose papers in the air. That juggling requires immense working memory, which burns ATP, which causes the KTTP channels to close the save energy.
Ah, so it's an energy conservation response.
Exactly. This sequential gating paradigm dramatically reduces encoding competition in the receiver's brain. It allows their prefrontal cortex to safely process the signal on autopilot. You are essentially translating the content into native JAX or TPU algebraic schemas.
Right. JAX and TPU being the specialized hardware and software environments used to run massive AI models efficiently. So you're formatting the data so the human hardware can actually run it without overheating.
Precisely. And Protocol 3 takes us into the environment by co-creating symmetrical sandboxes like Lego therapy.
Lego therapy? You're talking about rigid role assignment, correct?
Exactly. You establish a structured, pre-agreed spatial baseline. You have the engineer who manages safety and structural geometry, and the supplier who delivers the high-fidelity emotional bricks. By assigning these rigid roles, you taskify intimacy.
Taskify intimacy. That's an interesting phrase.
You prove to the receiver's pattern-seeking system that their structural geometry cannot exist without your energetic supply. This isn't just measuring the ocean. This is building a pressurized decompression chamber so the two systems can actually dock and exchange resources without imploding.
Okay, let's look closely at what you're optimizing for here, because I think this is where the algorithmic lens reveals a critical flaw in this highly structured approach.
A flaw?
Yes. In standard benchmarks, we are optimizing for broad, generalized consistency. For instance, in the multi-analyte dataset tests, switching from an accuracy metric to a macro F1 score showed a negligible difference compared to the massive variance caused by data noise and discriminability. The goal of benchmark transparency is generalized robustness. We want to condition the metric on the data profile so the system can operate across a wide variety of standard baselines, not just one specific sandbox.
But the baseline itself is the core of the problem. It suffers from what the framework calls the single MNM problem.
Explain that.
Imagine you need 2,000 calories a day to survive, but society is only built to hand you one single MNM every hour. That is a flat baseline. Standard, public-facing social dynamics rely on the repetition of tiny, uniform, low-value rewards.
Okay, I follow you.
You aren't failing because you can't eat the M&M. You're failing because the environment structurally starves your specialized metabolic needs. In twice exceptional dynamics, forcing the relationship to optimize for these flat standard repetitions prevents expert-level synchronization entirely. It drains the metabolic reserves of the spiky asset to absolute zero.
And your alternative to the M&M is what? The cognitive jackpot?
Yes, the symmetrical solution. By delivering a relational synthesis proposal as an immaculate, peer-to-peer structured specification using those PREP protocols and sandboxes we just talked about, it acts as a maximum magnitude reward.
Right.
This is backed by 2026 HHMII and Harvard studies. This cognitive jackpot triggers an extended, high-volume dopamine wave. It exerts a one-shot update, a delta T, on the very next trial, instantly recalibrating behavioral vigor and prefrontal engagement. The payoff for both the transmitter and the system hits plus 100. Zero latency visual compression, zero data loss.
But if we build these symmetrical sandboxes and rely on 2026 HHMII and Harvard studies, showing this jackpot triggers an extended dopamine wave and a one-shot update, aren't we just severely overfitting the system? If we highly specify the matrix to achieve this plus 100 symmetrical synthesis payoff, don't we destroy the asset's ability to generalize to the broader public baseline entirely?
Overfitting?
Yes, overfitting. In machine learning, if you train a model to expect a perfect, noise-free, highly structured input, a jackpot, it will perform beautifully in the lab, but it will fail catastrophically the moment it encounters the messy, unformatted ambiguity of the real world. By building these rigid engineer-supplier roles, you might save the interaction in a localized vacuum, but you've rendered the twice-exceptional asset incapable of surviving in the actual flat baseline world.
I would argue they were already incapable of surviving the flat baseline world without suffering a negative infinity astrocytic drain. Overfitting is only a problem if the generalized baseline holds value.
And you're saying it doesn't?
For these highly complex, specialized assets, the general baseline holds no value. It is a 1% lossy channel that structurally starves them. You say we are overfitting. I say we are finally providing the correct biological and architectural operating system for a specialized processor. Think about a quantum computer.
Okay, a quantum computer.
A quantum computer isn't overfitted because it requires a near absolute zero vacuum to function. It requires that specific, highly rigid environment because its operations are vastly more complex than a standard desktop running at room temperature.
That's an interesting point, though I would definitely frame it differently. A quantum computer still needs to output data that classical computers can read and utilize. Otherwise, its calculations are functionally useless to the broader world.
Sure, but
And that translation layer requires benchmark transparency. If we want to navigate a world built on standardized baselines, our ultimate tool has to be transparency and measurement. By explicitly mapping data features like ambiguity, length, and difficulty, we prevent ourselves from overestimating an asset's generalized capabilities on unseen data.
Right.
We can calculate the exact standardized mean difference between the complex asset and the standard baseline. This allows us to accurately predict where the system will fail and where it will succeed. We give stakeholders a quantitative data similarity vector so they know exactly what they are dealing with.
And I maintain that knowing where the bridge is out doesn't help if you don't have the tools to build a new one.
That's fair.
If we do not actively bypass the prefrontal KETP brake by utilizing structural interventions like pre-gating, the zero-trust firewall, and peer-to-peer visual compression, the specialized asset will remain fundamentally devalued and topologically isolated. The data loss isn't just a statistical variance you can put on a chart. It's a metabolic crisis. Measurement is necessary, yes, but without architectural scaffolding, the asset is drained to zero.
Well, it seems we are arriving at a profound point of convergence, despite our very different lenses. Whether we are looking at a 135 different NLP models dropping 12 points in F1 score due to unseen data difficulty, or a twice exceptional human mind suffering a complete prefrontal freeze state when starved by the single M&M problem, standard, uniform baselines are disastrously ill-equipped to handle high-complexity, spiky data.
Absolutely. The assumption that a flat baseline is a neutral, fair testing ground is entirely shattered by both the algorithmic data and the bioenergetic reality. The public-facing standard is a low-fidelity channel, and forcing high-fidelity data through it results in systemic failure every single time.
The question remains how we adapt. Do we prioritize the thermometer, measuring the variance of the ocean to predict the hull's integrity, or do we prioritize the jacket, building a pressurized sandbox to ensure the sailor survive the depth?
Both require a lot of further study, honestly.
Indeed. There is far more depth to explore in both the NLP benchmark studies and the socioeconomic bioenergetic research. We'll leave it to you, the listener, to decide whether the path forward is through the absolute clarity of the dataset similarity vector or the structural scaffolding of the symmetrical solution. We started by asking why a Formula One engine stalls on a dirt track. Perhaps the answer isn't just measuring the octane of the fuel or rebuilding the entire engine to tolerate the dirt, but finally recognizing that we've been running the test on the wrong track all along.